sure you are doing great over there. It's really nice meeting you once again. And if it's your first time watching my video, I'd like you to subscribe. Don't forget to like, share with your friends. For a short period of time now, I've been uploading videos on motions. Last time we discussed about the formulas, the applications, using some questions. And now today we are advancing to the velocity time graph. So the velocity time graph is just a diagrammatic or graphical representation of motion. There are some analytical form using the calculations and the formula. But this one is a method of solving the motion questions using the graph, and we call it the velocity time graph. And velocity time graph is a graph of velocity against time. We're going to use a graph from the questions and what the questions stipulate obtained from the graph. So it has been very known to us using the graph. So when the question indicates use a graph, you just have to adhere to instruction by using the graph. So we're going to plot a vertical and horizontal line. Let me call this vertical line the velocity, and the unit of course is meter per second, and the horizontal line is the time. The unit is seconds. So that means acceleration for me, and I take a speed of 80 meters per second. It starts from rest. Remember, when the car starts from rest, from our previous videos, I said when the car starts from rest, the initial velocity was 0. So that means the car starts from rest at 0 and accelerates, meaning from attained, but it attains a speed of 80 meters per second. So when it was accelerating, the speed it got was 80. So it got to 80. Now, what was the time? In 30 seconds. So within 30 seconds, so if here's my 40, the midpoint here will be my 30. Between 20 to 40, I'm sure my 30 will be here. So let me place my 30 here, 30 seconds. So the car accelerates. So let me draw my vertical line. 30 goes up, go up, yes. So to the point of this, my 80, yes, 80. So the car accelerates until get to a speed of 80 meters per second, and this is my speed. So you extend it at within the time of 30 seconds. So it goes up, yes. Within 30, so between the acceleration time 30 seconds and the speed it attains is 80 meters per second. So now that's the first stage. Now the next stage is that it maintains this steady speed for another 30 seconds. That is, the speed was uniform. The speed wasn't changing, it was constant. So it maintained this same 80 meters per second. It didn't change, but the time has changed. So when it was moving with this same speed, the time became for another was 30 seconds. So 30 plus another 30 gives 60. So at this point, let me call this my 60. So for another 10 seconds, it maintains this speed. It go up now. At the point where it maintains speed, it's horizontal. So it maintains this 80. So this my for that 30. So 30 plus 30 for another 10 seconds. So you add the 30 seconds plus the new 30 now, which becomes next 60 seconds. So this is the next. So draw it. Sorry, I'm using ruler. Just bear with me. Yes. For another 30 seconds. Now it then slows down uniformly, but it comes to rest in the next 30 seconds. So after it has maintained this speed for the next 10 seconds, so let me permit you to put the time here. Between here and here is 30 seconds. Yes, 30 seconds. Yes. Then between here and here as well, it's also 30 seconds. Now it then slows down. So what it means is that the velocity is not going up again and the velocity is coming down. You see, it slows down even though it comes to rest. When the vehicle comes to rest, means is 0. So the final velocity at this point now is coming to rest until a minus 0. But at what is the time between this 60 seconds when it comes to rest? Because the time interval it goes down gradually before it eventually stops. It's not instantaneous. So now they say for in the next 40 seconds, that is 60 plus 40 to give us 100. So this is the next 100 now. So when it comes to rest, for the next 40 seconds is at the point 100. So you draw the graph, goes down to come and meet the 100. So this is now 40 seconds. Yes, this is 40 seconds. Now, this is the graph. So let me call this stage 1, stage 1, stage 1, stage 2, stage 3. Yes, stage 1 was when it was accelerating. Stage 2 when it was constant speed, it wasn't changing. Then stage 3 was when it was coming to rest. So that's it. This is just a simple velocity time graph for the questions. Now, the question says, obtain from the graph uniform acceleration during the first stage of the journey. Now, solution now. A, uniform acceleration. Yeah. So remember, actually, when the car starts from rest, the initial velocity is what is 0. So during stage 1, u is equal to 0. What is v? The final velocity. When it attains this point, v is equal to what? 80 meters per second. And what's the time? The time was 30. So t is equal to what? 30 seconds. So the acceleration is what? 80 minus 0 over 30 is equal to what? 80 over 30, which is equal to 2.67. The unit of acceleration is what? Meter per second square. Meter per second square. So that's the answer for the first stage. Now, for the second stage, now, the ask us to say the retardation during the last stage, which is the third stage. The retardation during the last stage now, B now, the retardation during the last stage now, which happens to be the third stage now, is actually when the rate of change of velocity is decreasing. The velocity is decreasing now, and at this point, the velocity is coming towards rest. So, at this point now, let's look at the last stage now. This is the initial velocity, this is the final velocity. Now, the initial velocity at this point now is what? Is 80, because this is at the point where the body is about to come to rest. So, at this point, the initial velocity was 80, v is equal to 80 meters per second. Then the initial velocity, which is u, represented with u. Then the final velocity at which the body comes to rest is what? Is 0. Now, what's the time interval between when the body is 40 seconds? So now we calculate the retardation. Retardation is negative acceleration when the body is actually decreasing. The rate of change of speed is decreasing with time. So A as u as v minus u over t. So what is v? The v is what? The v now at this point is 0. 0 minus what is u? The u now, which is the initial velocity, what is 80. So and what is t? T is 40. So we have 80 divided by 40. So remember, 0 minus 80 give you negative 2 meters per second square. That's the answer. Why is it negative? Because it is decelerating. Deceleration is actually negative of acceleration when the body is coming to rest. When velocity is changing or decreasing with time. Then why the acceleration is positive is because the velocity is increasing with time. So that is how we arrive at our limit. So the vehicle used in travel the whole journey. And the time is, the first stage, the vehicle used stage 1. Stage 1, the vehicle used 30 seconds. 30 seconds. Stage 2 now, the vehicle used another 30 seconds. 30 seconds. Then stage 3, the vehicle used 40 seconds. 40 seconds. So what's the total time now? The total time the vehicle used 30 plus 30, 60 plus another 40 is what? Is 100. So the time the vehicle used in traveling is 100 seconds. So 100 seconds, that's the answer. Time equal to 100 seconds. So that's for question C. Now, the question D, please, I want to use this side of the word D. The time, and now I want to talk about the distance. Now, what's the total distance traveled? Now, there's a principle used in solving this kind of question. We take into consideration the shape. The stage 1, what is the shape? Is triangle. The stage 2, what is the shape? Is also is rectangle. And the stage 2, what is the shape? Is another triangle. And what the formula or the area for a triangle is actually half base times height. So the area for triangle, I think the area for the first shape now is what area of stage 1 is equal to 1/2 base times height. Yes, we calculate the distance in each of the journey by finding the area of the shape for each stage. So the area for stage 1 now is half base. So what is the base now? So we can say 1/2. The base is actually the time. Yes, the base is actually the time. From here to here is for 30 seconds. So times 30. Then what's the height? The height is what? It's actually the velocity. From here to this point now is the height. Looking at it as a triangle now. So what's the height? The value is what? 80. So it's equal to 80. So now what do we do? 30 times 80 divided by 2. 2 here 1, 2 here 15. So 20 times 200 meters. It's not in seconds because we are taking into consideration the distance now. Now the stage 2 now, stage 2 distance now, stage 2 now. Stage 2 actually has the shape of what? A rectangle. And what is the area of the rectangle? The area of the rectangle is what? Length times breadth. So stage 2 is length times breadth. Which equal to what? What is the length? And what is the breadth? So this is the length now. Length. So what is the difference between here and there is what? 30. And what is the thickness? Thickness is about 80. So from here to here is 30. We have 30 times what the breadth, which is the height, or length times height, which is 80 meters. So 80 meters per second. So by the time you multiply it, 30 times 400 meters. Then the stage 3 now, stage 3 now. Stage 3 now is also triangle from what you can see. Using the same formula, half base times height, which is what? Was 1/2. What the base? The base is 40 seconds. And what you can see from here, the base is 40 seconds. You can see it. So times 40. Then what's the height? The height is 80 meters per second. So 80. So now 2 here 1, 2 here 20. So 80 times 2, that is 16. So 1,600. So now the distance in each of the stages are 1,200, 1,400, 2,400, and third stage is 1,000. So the total distance for the journey is what? 1,200 plus 2,400 plus 1,600. 2,400 plus 1,600 to give us 4,000. 4,000 plus 1,200 to give us 5,200. So the total distance traveled is equal to what? 5,200 meters. Answer. So that's the answer for question C. So it's as simple as that. Apart from this method of breaking it into different shapes, we can also use a uniform, a single shape. And if you look at the shape now, is a trapezoidal. Is a trapezoid. It's having a trapezoidal shape. So you can use the formula for a trapezoid, and which is half sum of parallel side multiplied by the vertical side, then you get your answer. So that is it for this question. If you have your question or comment, please place it on the comment box, and we would like to update with any questions you have. Thank you very much. It's nice meeting with you, and look forward to seeing you in our next video. Please don't forget to subscribe, like, and share with your friends. Love you. See you.